Hey, hi everyone, welcome to this video. This is a new video series I'm doing on Cisco Packet Tracer. Getting started with Cisco Packet Tracer. So you've just entered the world of Cisco by now. So you've just entered the world of Cisco networking by starting to prepare for CCENT or CCNA, and would like to get a taste of everything in Cisco, but do not have the luxury to afford real hardware. Well, who needs a few pieces of real hardware when you can design complex technologies with tens, if not hundreds of Cisco devices and watch packets move between them? And do all of this on your laptop sitting anywhere. The best part is if you are an instructor or interviewer, practical questions can be created with Packet Tracer. You'll learn how to do this in chapter 11, getting Packet Tracer assessments. This chapter will guide you through the installation of Packet Tracer, describe its graphical interface, and show you how to create your first simple topology in it. Because this is a simulator, not all real-world, real hardware protocols are supported. So we will begin by seeing which protocols it does support. Protocols supported by Packet Tracer. A simulator, as the name suggests, simulates network devices and its environment. So protocols in Packet Tracer are coded to work and behave in the same way as they would on real hardware. The following table shows the protocols supported by Packet Tracer. Technology protocols: LAN, Ethernet, including CSMA, CD, 802.11, ABGN, wireless and PPoE, switching VLANs, 802.1Q, trunking VTP, DTP, STP, RSTP, multiplayer, switching, Ether channel, LACP and PAGP, TCP/IP, HTTP, HTTPS, DHCP, DHCP v6, Telnet, SSH, TFTP, DNS, TCP, UDP, IPv4, IPv6, ICMP, ICMPv6, ARP, IPv6, ND, FTP, SMTP, POP3, and voice over VoIP, VoIP, H.323. Routing: static, default, RIPv1, RIPv2, EIGRP, single area OSPF, multi-area OSPF, BGP, inter-VLAN routing redistribution, WAN, HDLC, SLARP, PPP, and frame relay security, IPsec, GRE, ISA, KMP, NTP, AAA, Radius, TACAX, SNMP, SSH, Syslog, CBAC, zone-based policy firewall, and IPS. QoS, Layer 2 QoS, Layer 3 DiffServ QoS, FIFO, hardware queues, priority queuing, custom queuing, WAID, fair queuing, MQC, and NBAR, miscellaneous ALCs, standard, extended, and named CDP, NAT, static, dynamic, inside, outside, and overload, and NAT v6. Installing Packet Tracer. To download Packet Tracer, go to www.netcad.com and log in with your Cisco Networking Academy credentials. Then click on Packet Tracer graphic and download the package appropriate for your operating system, Windows. Installation in Windows is pretty simple and straightforward. The setup comes in a single file named Packet Tracer setup 6.0.1.exe. Open this file to begin the setup wizard. Accept the license agreement, choose a location, and start the installation. Interface layout. The layout of Packet Tracer is divided into several components similar to a photo editor. Match the numbering in the following screenshot with the explanations given after it. The components of the Packet Tracer interface are as follows. Area 1, the menu bar. This is a common menu found in all software applications. It is used to open, save, print, change preferences, and so on. Area 2, main toolbar. This bar provides shortcut icons to menu options that are commonly accessed, such as open, save, zoom, undo, and redo. And on the right-hand side is an icon for entering network information for the current network. Area 3, logical workspace tabs. These tabs allow you to toggle between the logical and physical work areas. Area 4, this is the area where topologies are created and simulations are displayed. Area 5, common tools bar. This toolbar provides controls for manipulating topologies such as move, layout, place, note, delete, inspect, resize, shape, and add simple complex PDU. Area 6, real-time simulation tabs. These tabs are used to toggle between the real and simulation modes. Buttons are also provided to control the time and to capture the packets. Area 7, network component box. This component contains all of the network and end devices available with Packet Tracer and is further divided into two areas. Area 7A, device type selection box. This contains device categories. Area 7B, device specific selection box. When a device category is selected, this selection box displays the different device models within the category. Area 8, user created packet box. Users can create highly customized packets to test their topology from this area, and the results are displayed as a list. Creating a simple topology. Now that you're familiar with the GUI of Packet Tracer, you can create your first network topology by carrying out the following steps. 1. From the network component box, click on End Devices and drag and drop a generic PC icon and a generic laptop icon into the workplace. 2. Click on the connections, then click on the copper crossover, then on PC0 and select Fast Ethernet. After this, click on laptop 0 and select Fast Ethernet. The link status LED should show up in green, indicating that the link is up. 3. Click on the PC, go to the desktop tab, click on IP configuration and enter an IP address and subnet mask. In this topology, the default gateway and DNS server information is not needed as there are only 2 end devices in the network. 4. Close the window, open the laptop and assign an IP address to it in the same way. Make sure that both of the IP addresses are in the same subnet. So you can see here an IP address of 10.1.1.1 has been set and the subnet mask of 255.0.0.0, and the IP address for PC1 is 10.1.1.2 with a subnet mask of 255.0.0.0. Close the IP configuration box, open the command prompt and ping the IP address of the device at the end to check connectivity. So you can see they pinged 10.1.1.1 and you can see they've received a reply. What is a network topology without a single network device in it? Add an Ethernet switch to this topology so that more than 2 end devices can be connected by performing the following steps. Click on the switches from the device type selection box and insert any switch except switch PT empty into the workspace. Remove the link between the PC and the laptop using the delete tool from the common toolbar. 3. Choose the copper straight through cable and connect the PC and laptop with the switch. At this point, the link indicators on the switch are orange and color because the switch ports are undergoing and listening and learning the states of the spanning tree protocol, STP. 4. Once the link turns green as shown in the previous screenshot, ping again to check the connectivity. To save this topology, navigate to File, Save As, and choose a location. The topology will be saved with a .pkt extension with the devices in the same state. Summary: you have successfully installed Packet Tracer and used it to create a simple topology. Keep trying different topologies with only PCs and laptops and switches to familiarize yourself with the GUI. You've also seen a list of protocols supported by Packet Tracer. Use this list as a reference whenever you want to try a new technology in the future. Make sure that the protocols are configured and fully supported by Packet Tracer before moving ahead. In the next chapter, you'll learn about the different types of network devices and how to customize them according to your needs. You'll also see how to configure them through the CLI as well as through the graphical interface. So I'm going to leave it here today for this video on Cisco Packet Tracer. If you like listening, please consider like, sharing and subscribing. Thank you.